Hello, everyone, and thank you for joining us for the Blockchain in Healthcare webinar series. I'm delighted to introduce our guest speakers in just a moment, and I'm Heather Flannery, your host. Before we get started, I just wanted to quickly run through the format of the event so you know what to expect. You are in listen-only mode. You don't need to worry about muting. We're going to go through 30 minutes of presentations, ask the audience a couple of questions about your knowledge and experience and interest at the intersection of blockchain and AI. We're then going to have a panel discussion and a full 40 minutes of audience engagement. So you'll notice in your GoToWebinar utility, there's a question and answer dialog box. When we get to the Q&A section, I'll be taking questioners off of mute. You'll be having dialogue in audio with the panel, and we'll be putting you back on mute. So thank you for capturing your questions, and you'll get an advance warning when we're ready to go. So with that, I'd like to have our two panelists introduce themselves. Maybe we could start with you, Dr. Neal. Could you tell the audience about yourself and a little bit of your history?
Yeah, so Jack Neal, I'm a practicing pediatric anesthesiologist in the North Carolina, USA area. My background was my undergrad was in computer information systems. I went into medicine because it was kind of hard to find a job in 2003 in that field. So then my passion's always been back with IT. So once I finished all the 10 years of training, I've sort of eased back over, and now I'm working on, it took a year to catch up on all the new advancements because technology has moved so fast. But now for the past 2 years, I've been working on neural networks and some Internet of Things connected kind of edge neural network concepts, and then more recently in the past year or so, some blockchain projects, the way they fit into that whole realm. So that's a very short version of my life.
Yeah, really looking forward to exploring more of that during this event, and it's terrific to have a practicing clinician who's also an AI practitioner give his perspective. So thank you, Dr. Neal, for joining us this evening. And David, so delighted you could join us tonight. Would you mind providing an introduction?
Happy to. Thanks for the opportunity, Heather. Always great to be on the webinars, and it's an honor to present here with you both. So David Houlding, I am the principal healthcare lead with the Cloud and Enterprise Group, the industry experiences team at Microsoft. And I've had over 24 years of experience in healthcare across the different segments, payer, provider, pharmaceuticals, life sciences. And in my role, I'm very 100% focused on healthcare and worldwide, really seeking to understand what are the trends driving change in healthcare. What are the challenges, the pain points? What are the strategies, the sort of transformative things happening? And what are the business needs? Ultimately, how to meet those business needs. What are all the pieces of the puzzle? Some of them are technology, some are not technology, like policy or compliance, things like that, training, people, process. Seeking to understand all the pieces of the puzzle, help healthcare understand how they can meet their business needs. And then, some of the pieces of the puzzle are technology. So, where technology can help. Oftentimes, Microsoft has a solution. The particular technologies I'm focused on within the Cloud and Enterprise Group are the cloud technologies, so Microsoft Azure, whether it's, we call it hybrid cloud. So whether it's on-prem workloads, with Azure Stack, or whether it's in the sort of Azure cloud, facilitating healthcare workloads in the cloud is one of the things we do. And some of those workloads are blockchain, and some are AI machine learning. You've got Internet of Medical Things feeding in. So this webinar is of particular interest to me because I'm deep in the area of blockchain. Done a lot of work in how blockchain can help advance AI and machine learning. And so really interested to share some ideas, provoke some thought and questions, and have some debate.
Yes, we definitely shall not neglect the realm of controversy. This is a very hot topic, and I know once we get through some foundations and fundamentals, it'll be fun to dig into some of that. And I encourage the audience to bring it on when we get to that point of it. And it's also really neat, David, listening to you describe where Microsoft is at. As a Microsoft alum, it's really exciting to see where the company is going. It's been a long time since I've been at Microsoft, but that's just wonderful to see.
Yeah,
So,
super.
yeah. So we're going to have Dr. Neil present first, and then David. But before we do that, we wanted to get a sense of you, the audience, with respect to your primary interests in the topic of this webinar. So if you could select just one of the following, if you had to pick a primary interest, is it AI and machine learning? Is it blockchain and DLT, or the relationship between the two, or healthcare innovation in general and looking for solutions there? So we can see, or I can see on my side, the percentage of the audience that has voted, and then I'm going to close the poll and display the results on the aggregate to everyone. So when we get to 90% of the audience, I'm going to go ahead and close the poll and display the results. We're at 75% now. So if you're online, thanks so much. You should see a little pop-up if you wouldn't mind just giving us that feedback. All right. Terrific. Thank you very much. I'm going to go ahead and share the results. Okay, interesting. So what do you think? We've got, for anybody who's listening in audio only, we've got 38% of the audience interested in the relationship between blockchain and AI, particularly as the highest segment, and then close behind it, healthcare innovation and blockchain and DLT. So what do you think about that, Dr. Neil and David?
Yeah, this is really interesting. I think the intersection between the two is absolutely where we anticipated to go deep. So it's great to see that, that there's a lot of receptivity to that. But it was interesting to me that blockchain was significantly higher than AI machine learning. And in general, I'm very active on social media with LinkedIn and Twitter, and that's what I'm seeing as well. There's a ton of interest and appetite around blockchain. But I think oftentimes people underappreciate the transformative effect that AI machine learning can have. So hopefully we'll share some ideas around that. And there was also significant interest in healthcare innovation. And I think what that's saying to me is we need to spend some time on really tangible healthcare use cases around blockchain and AI machine learning, not just talk about the technology, but how is this applied, what use cases?
Absolutely.
Yeah, the healthcare innovation, of course, as a provider, I'm jaded in all of this, but, that's exciting to see that some people chose that as number one, or at least a fourth about of people. That shows that we're not stuck on any particular technological solution. We're just looking for solutions. And so that's good to see that.
Absolutely.
Absolutely. So David and I are going to drop off webcam now, and I'm going to transition presenter to you, Dr. Neil, and then I'll do the same for you, David. Then we'll all three be back on.
All right, sounds good.
All right, over to you, Dr. Neil.
All right. Well, howdy, everybody. I'm Jack Neil. Let's get you on the full screen here. All right. So yeah, I'm a pediatric anesthesiologist, chief technology officer for Medstream. Also, let me get this off the side. There you go. Also have have a startup company that I run, and then a kind of intellectual property holding company I run. So let's get into this. Let's see if I can make it go. There we go. All right. So first off, you don't know Jack, so who is he? So here's the more detailed ledger of my history. So training with computer information systems at South Carolina, then a doctor of medicine there as well, anesthesia residency, and then pediatric anesthesia fellowship at Michigan is where that happened. I'm currently on the American Society of Anesthesiology's Electronic Media and Information Technology Committee. There, I just published an article last month, or actually this month, June 2018, on artificial intelligence coming to rescue you or to replace you. That's geared toward the providers. So it's not quite as technical as some things that we talk about, but still for the audience base, that might be an interesting read if you Google that. After that, for Medstream, we developed our own anesthesia, basically anesthesia EMR for other people who aren't in anesthesia. That's what it is. And that's for smaller hospital systems that has fault tolerance for network interruptions. So it does a synchronization event when it can. So that's a big problem with some of the major EMRs is when the network goes down, they collapse. Ours has to handle it because it happens all the time in small hospitals. So that was a challenge, but that's deployed at about 20 hospitals now. Our Medstream has 57 hospitals. We're about 150 docs, about 300 CRNAs, something along those lines. Then the startup we founded back in December, Zather is a company I'm working with 2 co-founders in London on. It is a system for crowdsourced, as you can see here, crowdsourced machine learning training data acquisition. It also will be allow people to monetize their personal data, specifically HealthKit. Once Apple gets HealthKit integrated, that's one of the goals is for us to be able to allow you to monetize data from there, to share it with research organizations, to share it with pharmaceutical companies. Again, this type of information, it's necessary for there to be a way for normal people, not just entities, to be able to transact this data and make money off of it, because in the historical way of de-identified data sets, I have a feeling those are going to go away within 5 years, or maybe quicker, more quickly than that, as ML is able to re-identify a lot of these data sets. So I think it's going to go back to a personal consent, kind of like GDPR for personal data over in Europe. So that's what Zather is. And then Udifi, sort of my project company. I love to program, kind of addicted to it, unfortunately. And so I program lots of different languages, lots of different systems, and you can see some of them here. I'll give an example of 1 or 2 of them in a little bit. But so yeah, Udifi is sort of just my personal intellectual property holding company to protect me, since some of these developments are in the healthcare industry and other sensitive areas. So that's me. We've already talked about Zather there, so we'll skip through this. And then Udifi, we've breached on as well, but we'll kind of come back to that in a minute. So kind of my area here, David's going to talk a little more about some of the technical side. I'm just sticking to a pretty broad overview of what ruins our life in medicine. What does the provider need out of this? What are our use cases? What are our pain points? And so here we go. So first off, one of the major areas, and sorry, I'm gonna be looking over at my other screen since it has my notes on it, so I'm not playing Candy Crush, I swear. So with the medical records, if you're a physician or if you're involved in healthcare, you understand this. We have so much medical information now for each patient. You know, one patient's medical record grows by about 4 megabytes a year, and that doesn't count wearable data that's starting to flow in. So that's a lot of data just from the size, but it's also, if you're a provider, how do you look at that data? I mean, you can't see it all. So in order to assist with that, you know, that's where, let's see if it works. Yes. That's where, that's the symbol for neural networks or machine learning or AI. That's where those systems for AI can come in to help augment our intelligence, to help us to see where the trends are going away from what's normal, so that we can pay special attention, because we cannot look through the entire record. We don't have enough time in the day. And that's also leading to, you know, over 50% of providers say they're burnt out on studies now. And the number one reason is health record systems. And it kind of is not just this, but also the third point there, charting and documentation overload. But between those two, that's one of the major reasons. So next up, journal overload. What does that mean? Well, the amount of medical data, the medical journal articles published, there's over 800,000 a year being published. There is no way any provider can actually review that to be able to identify what's important out of those articles. So that's a place where artificial intelligence can help us a lot. And some of the stuff IBM's doing, they're doing natural language processing, looking through journals. They just, I guess 2 days ago, maybe it was yesterday, they had the conversational debate where they had looked through a lot of health record, or not just health record data, but large data sets and aggregated facts to do a debate against a human. So that type of, that's coming. That's probably one of the more realistic use cases that we'll get to sooner than later, because just showing us the most important records and aggregating some of that information can help us to keep up with this vast amount of knowledge. because we're the same humans we were 20 years ago before all this existed. We need help. Charting and documentation. In this one, this is just, we spend the last study, I think it was 2010-ish, but physicians, even at that point, were spending about 60% of their day doing paperwork, and paperwork really means computer work. But that's disheartening. Your goal is to take care of patients, and that hurts. That hurts so much. This is another place where AI can help, specifically with some computer vision to try to automate charting. As natural language processing improves for dictation purposes, there's many areas that it can help us, which I won't go into because it would take the rest of this talk, but that's just another area. Unstructured data is another major area where neural networks AI can help us. Currently, it's estimated that about 80% of all medical data is unstructured, which means until we get systems via machine learning that are able to at least reasonably structure that data, it can't be used for further study very well. So that's an important place. The analog aspect of this is EKGs, EEGs, invasive catheters, things like that have waveform data. It may be digital waveform data, but it's still not discrete data. It's a continuous waveform. So that's a place where we can identify patterns. And then acoustics and sounds are another one for analog data where neural networks can help us. And I'll show an example in just a second. Lack of access to data. This is a place where blockchains can help us. Get us past the data silos, help with interoperability, and we'll get more deeply into this. Normally I love to go deep on these things, but I don't have time to. So we'll talk more deeply in a few minutes. Consent management. This is kind of where Zather was aiming for a little bit. We're able to handle personal consent for data transmission and for data sharing, and then ownership as well. Who owns it? Is it the person, the device, the facility? Blockchain helps a lot with that, with assigning ownership and having it continuously auditable. Medical record security. This is one where kind of both neural networks and AI can help. Neural networks can help with there's a couple companies already doing this. I don't know if I'm supposed to pitch anything, but like Darktrace is one, and I have nothing to do with them, so this is not a pitch. But there are companies who are using neural networks to try to identify, and there's a lot of them actually, that are identifying patterns that seem abnormal during access that can help. And then blockchain can help here. One use case or one example that's scary is with medical record terrorism. If someone gained access to a large data system, they could change a few records, but change them in a way that when care was provided based upon that change, it would cause either morbidity or mortality to the patient. Having a blockchain system that's secure and cryptographically signed could at least allow a backdrop to audit the change against continuously to see if this is a dangerous change that may lead to morbidity or mortality. And then lastly, device interoperability and security. This is another one where EHRs have a lot of difficulty integrating medical device data. I mean, it's not that hard. It takes quite a bit of IT manpower. So if devices can write their data into a uniform system that then has that access control where other people can enroll to access it, that's another place where blockchain can help. And there's my contact information. We can probably put it back up later, but just for the next 3 minutes, I just want to show two examples of some of this in action. So over here, unless you want to read about Enigma price balances, we won't do that. So here's a simple kind of emergency health record system that this is completely runs client side. This is all the records are encrypted and written onto the Ethereum blockchain, which, as we'll talk about, not a great idea, and hospitals can't do this, but a patient could do this because this would never be HIPAA compliant to write it on here, but the patient can do it for just emergency medical records. So what I'd like for someone to do is if one of our attendees can pull out your phone and scan that QR code. This is a QR code. First, I'll show you this is the QR code that would be generated by clicking this button. So you would click here and it would create a QR code, and then you would actually print a card, and this would be a card you put in your wallet. So after you'd updated your record, this would be in your wallet and someone could scan it. So now if someone would scan this code, and what you're going to see, we'll see if someone's done it yet. Let's see. Over here, not yet. Okay, so if someone has scanned it, type this code in, 335337. There's a box on the page that pops up that says sync. If you type in this code, you will see that it fills in, and if no one does this, we'll just move on. We're just giving it a try.
Dr. Neal, this is Heather. The audience doesn't have any convenient way to communicate with us at this phase, but we may be able to do something during the facilitated audience Q&A where we could have someone do this live. Yeah.
Sounds good. And then here's just a simple example of a neural network that's done on acoustics that's going to be trained for other hospital sounds. This is actually my son, but this is doing the cry detection, just to show some of the two different systems that are actually working and in place. And that's it for me.
All right. Thank you, Dr. Neal. I'm going to go ahead and make David a presenter. Just a second.
All right, sounds good.
All right, and Dr. Neal, you can drop off webcam and then come back on as soon as David is finished with his talk.
All right.
Okay, great. Let me know when you can see this okay.
You are good to go.
All right, super. So really interesting points by Dr. Neal. What particularly stood out for me was too much data, not enough time. AI machine learning is just becoming increasingly essential. Doctors are getting swamped, and all healthcare workers are getting swamped with information. And if they're drowning in information today, that's just going to be exacerbated going forward with consumer health, wearables, Internet of Medical Things, etc. Also the AI for machine learning, for AI and machine learning rather, for cybersecurity was really of interest to me, given my sort of background in security, privacy, compliance. And I know that there's very exciting work going on with Darktrace and FiBreaks and others to detect anomalies on the network. If ransomware lands on a medical device and it's beaconing to its command and control server, that can be detected by AI machine learning. And once the detection is made, one can stop loss and remediate. And a lot of security is about detection and remediation. It's not only about prevention. So detecting ransomware, detecting system vulnerabilities, detecting employees doing risky things, and once it's detected, stopping loss or remediating. Super essential, especially for healthcare providers that can't afford the disruption of ransomware and things like that. So anyway, I digress. Let's get back to healthcare, AI, and blockchain. So where I'm going to add a lot of color is on the technical side to augment what we learned from Dr. Neal. And if we're talking about, this is very squarely in the area of interest from the initial poll of the intersection of AI and blockchain. One can look at a sort of layered view that shows how they intersect. And in layer 0 is where we are today, that we've got a ton of data in various, healthcare organizations in various silos, whether it's an EHR or some other system, lab systems, radiology, et cetera, payer systems. There's all these silos, right? There's very little, if any, sharing. There's massive untapped potential is generally what I've seen, where the consensus is that most healthcare organizations and workers agree there's massive untapped potential to share some of that data in a targeted, secure manner to improve healthcare, whether it's reducing healthcare costs, whether it's improving the experience of the patients and healthcare workers, whether it's improving patient outcomes. There's massive untapped potential. So that really paves the way for layer 1, which is blockchain. Blockchain can enable that targeted, secure sharing of healthcare data across what we're going to call B2B or business-to-business networks. So think of a network of healthcare organizations that need to share a certain type of data, and for a defined business reason. And blockchain is the B2B middleware that can facilitate that targeted, secure sharing. Blockchain can deliver value in the form of that targeted, secure sharing of data, independent of smart contracts or cryptocurrencies. Okay, so just think of it as baseline in layer one. It can be a sort of data conveyance, collaboration platform, a middleware. Layer two is, once we have that sort of baseline layer one, we can add layer two, which can increasingly automate transactions on the blockchain. So in layer one, all the logic is on the periphery of the blockchain. It's in the enterprise systems that will connect to the blockchain. Implicit in this is that blockchain will not replace those. It's going to augment those enterprise systems. It's going to connect with them on the back end. And but in layer one, you've got the execution, the logic in those enterprise systems, not on the blockchain. So why would you want to move the execution to the blockchain? Well, it could be a lot faster, and you could offload a lot of the execution to the blockchain. So let's say you're doing a clearinghouse where a provider is generating a claim that's going to a payer. If you do that via blockchain, and there's companies doing that like PocketDoc, the actual claim has to go into the payer system, be processed, adjudicated, the results put back on the blockchain, and there's certain turnaround and response time delays, if you will. A lot of that adjudication, the simpler sort of claims adjudication, could potentially move to the blockchain. So you can have executable logic on the blockchain that as soon as a new transaction is seen that matches the smart contract, it can execute, and it can kick back claims that are invalid for whatever reason, and thereby improve a response and efficiency and lower costs. In layer three, once we have smart contracts, that paves the way for cryptocurrencies and tokens. So a lot of you will know about Bitcoin. We're not talking about Bitcoin here, and like in layer one, blockchain is very distinctly different from Bitcoin. Think of blockchain as a foundation that supports a lot of different sort of applications. Bitcoin is one application, but healthcare has many, many applications. But cryptocurrencies and tokens can be used in layer three to enable sort of new types of commerce around healthcare use cases and new incentive systems. So, if you're doing a blockchain around a use case that requires patient engagement, you can incent and reward that patient engagement with cryptocurrencies and tokens. So they'll be rewarded for sharing their data, participating in studies, and they can redeem those rewards for reduced cost on their healthcare services or any number of sort of rewards. So layer three can incent collaboration amongst healthcare organizations and so on. So now where layer four fits in AI and machine learning can really be advanced with blockchain and related technologies here. AI and machine learning, they're very data hungry, right? They need lots of data. They need high quality data. Where blockchain can help is, any AI machine learning project ultimately runs into the obstacle of there's not enough data. We can source data out of this one organization, out of this one silo, but it's limited data. At some point, you're not going to have enough data to do some corner use cases or drive the models to a level where you're going to get a low enough error rate to make it feasible. To reduce error rates and to improve inference, you really need lots and lots of data, lots of high quality data. And so where you get that from is not just one organization or one silo, it's a consortium of organizations, and blockchain facilitates the secure targeted sharing of that data for the purpose of training AI machine learning models. And blockchain can incent the collaboration around AI machine learning in many other ways, which I'll go through in a moment. But I like to do this sort of layered view because it kind of shows how they support each other. Blockchain is really a foundation that can support better AI and machine learning and many other higher level functionalities. So I'll advance. So we talked about how blockchain is this B2B middleware. You can see in the sort of middle of the diagram here. And you've got the healthcare organizations on the periphery. You can see the red dotted line is the enterprise internal firewall. So the blockchain nodes, the blue squares, they're either running on-prem in the DMZ of the healthcare organizations, or they're running in the cloud. And it can be on a case by case. You could have a mix. You could have a blockchain network where some nodes are on-prem, some are in the cloud. It can really be a heterogeneous deployment environment, much like the internet, right? You're not going to find all nodes in one place or all nodes on-prem. It could be a mix. but the nodes have to speak the same language. So if, a given blockchain network picks, Hyperledger Fabric, then they all need to be Hyperledger Fabric to talk to each other, right? The blockchain nodes have to talk to each other. Their sort of mission in life is to maintain the validity and consistency of the decentralized ledger, the ledger that each one maintains. And you can think of that as a sort of shared database. It's not quite a database because it's more like a linear record of transactions, but it's shared data, right? It's data that's shared to support a particular use case. So that's really what to take away from this diagram is the blockchain network is the middleware. It sits between the organizations. The nodes are outside of the firewall of the organizations. So implicit in this is privacy, security, and compliance are incredibly important, right? If you're putting data outside of your firewall, we need to make sure that we cover privacy, security, compliance. And I spend a lot of time in that area in general, and especially with blockchain. Blockchain is not a panacea for security. It's not a silver bullet. It has some strengths with security in terms of immutability of the ledger, protecting the integrity of data on the ledgers. And the protecting the availability of the overall network because there's no single point of failure. But there's a lot of additional things you need to do to ensure privacy, security, compliance with blockchain, and I spend a lot of time in that area. But good news is it is achievable. There's many blockchains happening that are going to be compliant with regulations and data protection laws. So, but the takeaway from this is as you're considering blockchain, definitely pay careful attention to privacy, security, compliance, engage your respective teams early, because it can impact, whether a given use case is feasible, what type of data you put on the blockchain, where you put your blockchain nodes. Those can all be influenced by, privacy, security, and compliance requirements. So if we look at, a cloud-based option for deployment of blockchain, a lot of healthcare organizations are into a mode of piloting blockchain this year. And they're looking for easy options to prototype blockchain and to spin up nodes. And it's generally a lot easier to spin up blockchain nodes in a cloud than to set them up in the DMZ of your organization. Ship hardware, configure the hardware stack, or the software stack on the hardware you procure. Deploy it in your DMZ, open up firewall ports, etc. That tends to be a longer process than to if you were just spinning up blockchain nodes in the cloud. And it can be multiple nodes because you could have nodes across, availability zones. You could have load balancing, automated failover, especially as blockchain moves towards production. The fault tolerance, sort of reliability of the blockchain is important. But a lot of blockchain is going to support higher level functionality, like we talked about in the previous slide. Is analytics, AI, machine learning can run on top of blockchain, and guess where those things are running? They're mostly running in the cloud now. So you can co-locate those with your blockchain nodes in the cloud. So you also have things like backup and restore. You've got business continuity, disaster recovery, and oftentimes high performance sort of index databases alongside your blockchain to improve the sort of read performance. Blockchain again is not really a database. It hasn't got like high performance, millions of transactions a second sort of read performance. If you want that kind of performance, what you want to do is index your blockchain, your ledger. And good news is the blocks in the chain are immutable. So once the index has read them once, it doesn't have to read those blocks again. So you can build a very high performance sort of index relational database that facilitates very high speed read and search of your blockchain data. So the opportunities to advance AI with blockchain, and this is to the heart of the key interest that we saw from the poll earlier. If we look at sort of AI machine learning, in terms of a 4-step process, we've got our training data on the left, we've got our models that are trained based on that data, we've got inference results, and we've got the validations of those results. So how do we trust a model? How do we trust what it's telling us? Well, we have to validate those results, right, with non-AI machine learning methods. And but the validations of those results are something that takes a lot of work. And we can share validations of results just like we can share training data. And in sharing validations, we can collectively learn to trust AI machine learning a lot faster than if we go at it alone, like one organization alone. So on the left-hand side, training data can come from multiple organizations facilitated by blockchain. Imagine, you have a use case in blockchain where you've got a group of healthcare providers, and each one, as it acquires new data, can put some metadata on the blockchain about what data they have, and a pointer. Where does that data reside? What provider, et cetera, hash code to verify its integrity. The rest of the provider network can then search that blockchain, see, oh, there's this data that I need for this model I'm building, facilitate the secure exchange of that data to facilitate, training that model. It might be a model targeted at a very specific, patient condition. And so that ability to search across sort of the union of all data in the consortium is a much more powerful than sourcing that data just from one silo in one organization. Blockchain is also really well suited to track things like provenance. So if you have provenance information about your data, that can be on blockchain. And you can use that to filter out the highest quality data to train models and thereby improve the quality of the models as well, and the quality of the inference and lower error rates. If you happen to have a problem with a biased model, you can look back at the provenance, what data was used to train this model. So the blockchain can store audit information, what data went into what model. And if you have a problem with a model, if it's biased, you can go back and see, okay, this is the data, and root out the data that's causing the bias, and improve your model that way. The blockchain can have both on and off chain data. So sometimes the data is on chain, but oftentimes healthcare data will be off the blockchain. So it'll just be metadata that's going on the blockchain, and it's referencing, it's pointing to off-chain sort of secure access controlled repositories for that data. And obviously the AI machine learning can either run directly on the data on the blockchain, or it can be used to you can train AI machine learning using data that is referenced by the blockchain and retrieved separately. Sometimes there's impediments to sharing data. It's also possible to pass the model around organizations and train it incrementally within each organization, kind of like pass the football. Each organization trains the model sort of incrementally and passes the model around, not the root data. And in that way, you can get around some of the impediments with sharing the actual training data. The blockchain can be used to protect the integrity of the models. You can take hash codes of models and put those on blockchain and verify the integrity of models, to prevent people from tinkering with models, unauthorized modification of models. We talked about shared models. You can incent collaboration over blockchain with cryptocurrencies and tokens. So if you want to incent the collaboration to advance AI and machine learning, you can do that via blockchain. So incenting sharing of training data, incenting training of models, and incenting the sharing of inference results and the validations of those results. So I think that just about covers it. There's also a very different use case here so we talked about how you can put executable code on the blockchain in the form of smart contracts. There is the idea of smart contracts being powered by AI machine learning, and even what's called DAOs, or distributed or decentralized autonomous organizations, being powered by AI machine learning. So that's where blockchain could use or call out to AI machine learning to help with its sort of execution. But as you can see, there's a ton of opportunity around advancing AI and machine learning with blockchain, and it's all about advancing it faster as a consortium, a collaboration of multiple healthcare organizations rather than going out of it alone. And that's really where the sweet spot of where blockchain can add value. So what can you do today? So by the way, these slides with the links on here are available in the handouts of this webinar. So you should be able to access those. It's a PDF and the links are active. So if you want to know what you can do today, there's a pretty handy healthcare blueprint for AI that you can download. It also goes into some of the compliance things with HIPAA, high trust. But you can download it from that link there. And it's actually not just documentation. You can actually run that. You can run that in Microsoft Azure today. And you can, of course, understand the components. It deals with the patient length of stay prediction, but that provides you a baseline that you can then customize to whatever the use case you have in mind for AI machine learning for your healthcare organization. The other thing I'll leave you with in terms of things you can do to get started is we have this Azure blockchain workbench. So this is a rapid prototyping environment. If you have a particular use case in mind for blockchain for healthcare, or any industry, you can go in there and you can prototype the blockchain sort of artifacts that you can then deploy to Ethereum Enterprise and soon Hyperledger Fabric and R3 Corda, running in Azure. Again, a lot easier to spin up blockchain nodes in the cloud. But you can get going with your pilot a lot faster and focus on piloting and sort of learning and evolving your blockchain rather than the technology. So that link there, you can go and see the Azure Blockchain Workbench. Lots of good information there about how to get started. I'll leave my contact information here. Again, download the handout, the PDF, and you can get this. But there's a ton of activity on social media. Feel free to reach out to me. These two subjects are evolving super quickly, and so it's not really something you go pick up a textbook. If you want the latest information, I encourage you to reach out on social media, or you can shoot me an email. My email address is there. With that, I will hand back to Heather.
All right, thank you very much, David. And Dr. Neal, you're welcome to come back on. David, while we have our dialogue, I think it would be terrific if we could leave that 4-column slide that had the it's slide 5 there.
Sure.
Maybe we could leave that as a backdrop as we're having our dialogue. I think that's such a terrific view. What do you think?
Yeah, that sounds good. Can you see it now?
Yeah, absolutely.
Okay,
yeah, well, thank you both for those presentations, and my goodness, there is so much to discuss. I think before I jump in with questions, I'm curious if Dr. Neal, you have any initial reactions to any aspects of David's presentation just ended, or any first thoughts?
Yeah, I mean, out of all of it, this is my favorite slide. First, I'm also excited to see Microsoft. I mean, I had already seen on Azure. I use Azure quite a bit, but David and I don't really know each other, but I happen to have seen some of the Azure Ethereum nodes you can spin up to run your own cloud server there. And that's nice when you're first learning and screwing it up a bunch, because you can easily decommission and restart. If you spin up your own, that's not quite that easy. So it's nice to see that's coming along with Hyperledger and R3 as well. So that's nice from the Microsoft side. But then just from the technical side, seeing this nice layout of it's a little bit of, Zather sort of doing it, but not currently using blockchain, but of course this all fits well for blockchain. It's just at the mercy of the blockchain advances that make it scalable, which is, it's so rapidly evolving that if it doesn't today, it might next week. So it's a little tough to plan a month from now or 3 months from now with the environment that we're in. So it also takes a tremendous amount of reading and testing to keep up, because AI and blockchain, these are the fastest moving. I'm 34 years old, but I've been in tech world. That's still a while, I guess. But this is the fastest moving I've ever seen the information technology industry. So yeah. So anybody who's watching this a year from now, you probably want to watch a newer episode, because this will probably be outdated a year from now. It just moves so fast. Yeah. But this slide won't be. This is a very a nice slide for kind of the things that will evolve and become more truth and more actual in use. So yeah.
That's great.
So one of the first concepts that I think it might be helpful to the audience if we dig into a little bit is discussing the differences between opaque artificial intelligence or opaque AI and explainable AI. And both of you mentioned that in your dialogue in different ways. And I think it might be helpful to take a couple steps back and say, what do we mean by those two concepts? And maybe provide an example of each. I'm thinking about work in imaging and audio files kind of being in one category, work based on traceable inferences of logic being in a different one, and some of the pros and cons, and also connecting that maybe to some of the reasons there is controversy at the heart of these topics. Who would like to react to that first?
I'll let Dr. Neal take that one.
Well, yeah, I'll take it from the provider side on kind of the acceptance, like what'll be accepted or at least initially. Of course, I'm not talking, who knows, 10 years from now, things will move fast, but in the foreseeable near future, for most, again, when you talk about narrow AI and you're talking about very specific use cases, you'll be able to find plenty that explainable AI won't be needed for, where it's really augmenting our intelligence. And even if you can't tell me why, it's okay if you can help me to not miss something. That'll be okay. One of the issues you'll see on the provider side is, where's the fault lie if I don't follow the AI recommendation, if it can't tell me why it made a recommendation. So if it tells me this patient likely is developing sepsis, or there is a vague area on, it can't tell me why, but on this x-ray it said that it looks like maybe early pneumonia, and then I have to act upon it as a provider, what do I do? Because it can't tell me why it made that prediction. So if I dismiss it and it turned out to be correct, where's the fault lie? So that's a place where explainable AI, when it comes to actual in day-to-day acceptance, it will be very helpful if it can say it's these pixels in this area on this image that made me think it looked like pneumonia, or if it's these pieces of the inputs from sepsis that made it predict that this patient's early sepsis. But that's where explainable AI, when it can tell you what inputs it weighted more heavily, and then I can, using my knowledge base, assess whether it was accurate, whether I believe it to be accurate or not. If it can't do that, it can be confusing to a provider. I'm not to be able to use that information comfortably, and some will put up just a don't show it to me because I don't want the ramifications if it was correct and I dismissed it. So that's a place where, on the true, when it's making predictions for diagnoses, especially, explainable AI will be much more helpful. And then David, you can talk about the difference between the two from the technical side.
That was a really good explanation from the provider side. And I'll just say, there's this TED talk that comes to mind. That was talking about AI, machine learning, and biased models, and they had trained this machine learning model with all of these images of, I think it was wolves, and then they had run inference, and the inference had picked up that something was a wolf when it actually wasn't. It was something in the snow. And what they discovered was most of the images used to train the model for detecting a wolf happened to be taken in the snow. And so the machine learning model had identified snow means a wolf. And so if you don't know why a model is generating inference in a certain way, you can really inadvertently end up with bias in your decision making. And if that decision is going to impact patient care, that can be a big problem, right? So as Dr. Neal was explaining, if the model can explain what are the regions that are heavily influencing this inference decision, it can help you zero in. Oh, it's not really looking at the wolf; it's looking at the snow, and that's not the right place to look. But that's just a simple example. But I think what I'll do is, if you're doing opaque AI and you're sort of treating it as a sort of black box, and you're looking at the data that goes in and the results that come out, and then validating those results. We can validate results using traditional medicine and diagnostic techniques and learn to trust the model from that, right? And if a model is tested many times across many organizations collaboratively via blockchain, we can learn to trust it a lot faster than if we try to test it and validate it just within our own organization with our own sort of limited head count. There have been efforts to sort of dissect models and why does a certain neural link have a certain weighting, and what does that mean? Does it mean a wolf? Does it mean snow? I think as models get more and more complex, that approach of trying to dissect individual weights inside models is going to be increasingly futile. And we're going to have to rely on, explainable AI and, validation of results. And if we can do that collectively via blockchain, we can be much more successful.
So a couple of points I'd like to surface out of the things that you both just said. I think one fear that healthcare providers, administrators, and policymakers have, and if we're going to sort of focus on the dark side for a moment, a fear is that various kinds of AI and machine learning will be utilized to develop an inference that is hypothetically clinically utilizable in some way, right? And then it will go straight from the point of having created some kind of inference or suggestion or model to use in practice, well before it's been validated through traditional experimental models, before it's been translated into any kind of guidelines, before the liabilities have been established, before lots of things have been worked out. And I think that practitioners in the field focused on healthcare are looking at AI in part as a mechanism of generating hypotheses that form research questions and inform experimental design that then are validated through classical empirical models. But we perhaps would never have developed those research questions. We perhaps would never have conceived of those notions were it not for a machine intelligence discovering something in a large data set. But there is still this clear separation between a discovery or an inference or a hypothesis and what's actually translated into practice, where hypothetically a lot of the provider concerns that you mentioned, Dr. Neal, should have been ameliorated in that process, hypothetically.
Yeah. One thing, David, interestingly, your wolf example is the exact example that got us to start Zather, which is very, very strange.
Wow.
It proved that a biased training set, you need the largest, most unbiased, disparate data set to train upon as possible for any AI training data. So for that, crowdsource just seemed the best way to spread it. Anyhow, that's a side note. Strange. But I agree, Heather. I think the low-hanging fruit is to use it behind the scenes to recognize patterns and inference, and then take that information and go the traditional route of randomized, double-blind, placebo-controlled studies. Like that's the safest way. Although most of the things we see in the news and media and publications of small-scale studies, they're actually looking to make diagnoses from it, and I think that leads to a little fear on the provider side, because that's kind of what's getting the media attention. And at some institutions, I feel like they've already started adding some like the sepsis prediction into their EMR, which they're kind of pushing it. And these things, there's a little, it's kind of almost any type of clinical decision support. It kind of skirts through FDA approval, right? If it was a true decision-making device, it would need approval. But they are supposed to help you, so they don't have the same level of the same requirement level to get approval. And an IT department that comes up with a nice model can push it, or at least they do push it out onto the EMR with what they've considered validation. And I think that scares providers. We've lived through different, especially the early sepsis expert control systems or expert systems when they predicted everybody had sepsis, right? I mean, in ICU, every day you were dismissing sepsis alerts. You got alert fatigue, you just ignored it anyhow. I think those types of things, that early push of new technology without explaining why, just fears providers. And I'm not talking as a IT, a guy with an IT background as a provider. I just mean for the majority of healthcare providers, that's a wall to climb. And so I like what you're saying is the idea of doing it behind the scenes to help generate hypotheses. But I kind of don't think that's going to happen. So I think a lot of the push is going to be forward.
So I think that what you're describing, like those early sepsis pseudo AI predictors, they've kind of given a bad name to this nascent field by skipping those critical steps. By contrast, you could take, we have imaging for diabetic retinopathy using AI imaging. We have radiology imaging that's gone through FDA approvals, and I'm particularly interested in Medtronics and IBM Watson together did the first FDA approved AI-driven hypoglycemia prevention model connected to their continuous glucose monitoring data. And that could be a talk in its own right on how they went through the validation models before that was ever FDA approved. But it was long since validated in really well-structured trials before it ever received approval. So I think it's so important that, if anything, if our community and our industry understands that does represent an appropriate and ethical set of actions in terms of discovery, leading to hypotheses, leading to valid experimental design and translation into practice, and not just skipping the steps like you described in that sepsis example.
Yeah, I would just add there, I think that the narrow AI is going to take root first because it's narrowly focused, and especially in the use cases where it's really easy to validate the results. I'll give you an example. If you're talking about AI machine learning to do dictation like we do on our smartphones now, a lot of us, if it messes up, right away because it gets the wrong word, right? So it's really easy. It can really help. It's an efficiency improvement, but if it messes up, it's really easy to find that and correct it. And so I think those kind of use cases where errors are easily evident will be the ones that take hold first. But there's another sort of compliance dimension to this. If you write software that does medical diagnostics and takes in data and then draws a conclusion about that data, like you are sick or you have this condition, that can be classified as a medical device for FDA regulation, right? The software, not just the hardware, right? And so, the same will go for AI machine learning. If it's doing medical diagnostics, it can be classified as a medical device, and there's kinds of constraints that go onto it that you can get into some serious trouble if you're doing that kind of inference. You haven't properly tested per the regulations. Now, I think one of the unfortunate side effects of that will be you'll see a lot of sort of AI machine learning mushrooms popping up in other countries that don't do as good a job regulating medical devices. And consumers will go to websites that are based in some third country and run inference on their data and get results back, and they won't really know that that hasn't been properly scrutinized and validated. So I think this could be very interesting. We could be near to a watershed moment in healthcare where to date, we're generating increasingly more data, as patients. We have the Fitbits and blood pressure cuffs, and you can get an EKG you can hook up to your smartphone now. And they tell us things that we then go research with the search engine. We educate ourselves. What does this mean, right? But I think the time is soon coming when you will be able to point that data to an AI machine learning model somewhere on the internet, may not be the US, and it'll actually do diagnostics on that data and tell you, in many cases, what may be useful things, but in some cases, it may give you dangerously wrong conclusions, right? So I think this is something we got to watch out for. So it could be a wonderful thing, but it could also be fired, be very aware, patient beware in this case.
Absolutely. And with increasing the combination of telemedicine with medical tourism, with the technologies you're describing, where patients will be able to leapfrog any jurisdictional or geographic boundary to get perhaps what they've been marketed. Whatever they've been marketed and they believe is so we have a whole constellation of ethical challenges to consider with this, but it is encouraging to note that we have examples of very legitimate, very validated solutions that are saving lives and creating outcomes that are going today, which is encouraging. I'd love to shift the conversation to unpack another topic that we've both discussed and that both of you mentioned, which is at this intersection of using blockchain and distributed ledger technologies as a way of assembling large data sets where we have hypothetically the provenance of every discrete data element, so that it can be more directly attributable to and traceable from an explainable perspective. We've talked before about this concept of data lakes and assembly of large data sets. would love to hear both of your reactions to that way, that point of connection of blockchain as the rails by which data lakes can be assembled and utilized. David, you want to react to that? I know
Sure.
you've given that a lot of thought.
Yeah, absolutely. So I kind of touched on this earlier, but let's go deeper. So the idea is, within a consortium of healthcare organizations, let's say a tiger team forms around a particular new project to do AI machine learning for dermatology, to do a sort of diagnostics on images of the skin to determine if a mole needs to be needs to have a biopsy or if it's most likely not malignant. So the idea there is you could either look for images within your own repository and you'll have limited data available of the type you're looking for, maybe limited provenance information. But with blockchain, you can search on a blockchain and there's participation across the consortium of healthcare providers participating. You could search and say, what are all the images available across the network of, of the type being looked for, based on the metadata. I'm looking for images of skin, with moles, etc., with information around them, like was this mole malignant, etc. And you're based on that metadata, you can determine, what's available, where is each data set. You can initiate secure requests, off blockchain to retrieve that information and create a data lake, that can then be used to, train models and run inference and, test results. That's sort of the technical idea behind it. And the good news is it doesn't require any PII or PHI on the blockchain. For those that aren't security and privacy geeks, it's personally identifiable information and protected healthcare information. Those can remain off the blockchain. They don't have to go on the blockchain. And in fact, there's good privacy, security, and compliance reasons where you may not want to put those on the blockchain, as well as performance reasons. You don't want to put all your images and heavyweight sort of genomic data and things on the blockchain. It'll grind it to a halt. So generally, it's metadata on the blockchain, like we described, and the retrieval of the information can happen based on the metadata that, as described, what's available and where is it. The blockchain can, of course, have, hash code information that can be used to verify the integrity of the data that's retrieved. But, that's the technology of it. What I'm going to give you a balanced response, I will say, sometimes there can be sort of privacy consent type impediments or business competitive impediments to sharing data and assembling it in a data lake like that. Where is the data lake? Who has all that data? Why should they have it, not me? I'm contributing too much data to that data lake. It's not fair. You get all these type of things coming in that that may get in the way of creating a data lake like that. And that's why one of the ways that this could be used, blockchain could be used to advance AI machine learning is to not necessarily share the data and create a data lake, but to rather collaboratively train a model incrementally by passing the model around the organizations and have each organization train the model incrementally without sharing the actual source data.
That's definitely one viable model. I want to come back to a point you made about where are those data lakes and who owns them and so on. But I'd like to give you a chance to react to that, Dr. Neal.
Yeah, and I think the tough part to discuss anytime we talk about this area is what is the blockchain? Where is it? There's so many different variations and models for how it could be structured. If it's a public blockchain, that changes everything versus private blockchains, which have permission. It's hard to lump them all together. You almost need a specific use case to then determine which model we're talking about. Because then otherwise you end up speaking very generically, which is hard to follow. I'm not talking about you, David. Yours was great. I just mean if I were to start talking about this, I would ramble on without a specific use case. I mean, if you're looking for a specific type of data, I personally, and this is an opinion, but based on GDPR and the Facebook debacle a few months ago, I think privacy is going to change completely, even when it comes to healthcare here. I have a feeling that even what's not considered PHI currently, if you de-identify it and take away identifiers, I think after a few more studies showing the re-identification potential, I think that kind of definition might even change on what is PHI or what can be re-identified. And that being said, I think a lot might go back all the way to the level of each and every share of a patient's information has to be authenticated by the patient. And if you go down to that level, now you have a whole different topic about what the blockchain does for you. Now the patient can sign and release sharing of their information at a personal level with it, and they can audit and see who accessed it, who's requesting access in an immutable ledger, and in that case, maybe a public ledger that everybody can see. It gets, unless we're talking about a very specific use case.
So in that scenario that you're describing, Dr. Neal, let's say we're talking about a public ledger where the patient's attestations of permissions and consent are persisted on that blockchain. In that scenario, we are not talking about their actual health data living in that blockchain. It could live in a lot of different places. It could live behind RESTful APIs and legacy systems. It could live in data banks of different kinds. It could live in cloud solutions that they own and control. It could live in distributed databases that are part of the same architecture as the blockchain, but not actually the blockchain.
Right.
Like the Interplanetary File System, IPFS, for example, or MongoDB or Accumulo, or a lot of infrastructure that is outside of the legacy systems, like you were describing, David. Nodes operating, in the DMZ, not behind the firewall, but there can be shared distributed databases that are tightly coupled with the blockchain infrastructure to manage that data, which may or may not be stored in this concept of a data lake. And a data lake could be spontaneously assembled, or it could be maintained and persisted to be reused with patient consent based on lots and lots of different AI training scenarios.
Yeah, super interesting point. As a privacy, I'll put my privacy hat on. Privacy is super important, right? If you do privacy well, you won't necessarily win, but if you do privacy badly, you could easily think, right? And we're seeing lots of very public examples of that. So privacy is super important. The really interesting thing about blockchain is it doesn't just add privacy risk, it's actually an incredibly powerful tool to empower the patient with privacy, the ability to see who accessed my data when, where is my data, review it, amend it, even exercise the right to be forgotten can be done via blockchain. Give consent, I consent to participate in a study, like you can have opt-ins and all that kind of stuff via blockchain. So it's it's almost a double-edged sword from a privacy standpoint. It can introduce privacy risk, but it can also be used as a very privacy sort of empowering tool for the patient. I just want to make one other observation is we're working with many different healthcare consortiums and startups on various blockchain use cases. There's probably about 10 of them right now that are in either piloting already or will pilot this year at some point. And the vast majority of them are private consortium blockchains, with the possible exception of public health. The only thing I've seen a public blockchain used for is cryptocurrencies and tokens to incent patients. But anything that comes remotely close to PII or PHI is on a private consortium blockchain. And that is because the healthcare organizations, in order to trust that only authorized individuals are going to access the data that they put on the blockchain, they want to know exactly what other organizations are connecting to that blockchain. They need to be well known and highly trusted. And that's what you have with the private consortium blockchain. This is an observation. I'm not advocating a private consortium blockchain. I'm giving you an observation that 99% of what I'm seeing is private consortium, because that way an organization, to build the trust where they're willing to connect and integrate and transact on a blockchain, you can assure them, hey, everybody that's going to see that data is well known, is highly trusted. You can have permissioning, you have read permissions, write permissions, validator permissions, kind of like permissions on a role-based access control, but on the organizational level. Then, of course, you can have encryption on top of that. You can be minimal but sufficient about what goes on the blockchain. And all of these sort of multi-layered security controls, security and privacy controls, are very necessary to get healthcare organizations comfortable with transacting on blockchain.
So a comment I'd like to make with that is I definitely can corroborate that observation in terms of what's happening now today. I think I'd like to add to it that importantly, these private blockchain consortia can represent milestones along an evolution where ultimately when policy, governance, scale, compliance, the use of side chains, for example, starts to make that distinction between private and public less and less meaningful. Hopefully, if these private consortia blockchains are designing with interoperability and forward compatibility in mind, ultimately those processes can start to activate the broader scale and the changes to incentive models that are only possible in the public scenarios. Um,
Yeah,
I
that's a
don't know.
really interesting thread of discussion. I mean, and I think we touched on this in an earlier panel you and I were on, but I think what we're going to see in the near term over the next sort of 6 months to a year is a sort of archipelago of blockchain islands, right? There's going to be an island for this use case, there's going to be an island for that use case, and the different islands will use different blockchains. Some will be Hyperledger Fabric, some Ethereum, some R3 Corda, etc. But over time, what will happen is consortiums that are successful in demonstrating business value and that get to the point of piloting, completing a pilot, doing a case study, a success story, demonstrate real business value with real healthcare organizations. Those islands are going to grow. You're going to get lots more healthcare organizations joining, not because blockchain's cool, because it's delivering real business value. It's helping them reduce costs. It's helping them do new transformative things that improve care. And so the islands will grow in terms of number of organizations. You'll also see islands grow in terms of use cases, like blockchains that are successful. The early sort of killer use case, if you will just be a beachhead. They'll layer on top all kinds of other use cases, and the island will grow both in terms of number of participants as well as the network effect. The cumulative value as more organizations join will go up, the more use cases are layered on a given blockchain. But I think one of the unfortunate impediments that's going to happen with these blockchain islands being separate initially is, for the next layer, the sort of smart contracts, the executable logic, they're constrained by what data goes on the blockchain and is visible. So if you limit blockchain data to one use case, there's a limit to the sort of richness of functionality you can put inside a smart contract or a DAO. And so we kind of almost we stunt the future growth the smaller the island is. So I think we need that sort of amalgamation of islands. That'll be the next step on the evolutionary curve, Heather, to your point, is the islands have to join, or one island grows and the other ones disappear. And we pave the way for richer smart contracts, richer AI, etc.
Yeah, I just, oh no, go ahead, Dr.
Go ahead. No, you go ahead. You were.
Well, I just a really quick point along that, bringing those two together, having the islands join. We've had two different solutions presented on this webinar series that we're using the Hyperledger Sawtooth Lake private model and specifically their crypto asset framework, and then using that to connect to the Ethereum mainnet to activate incentive structures and managing the consortia there in one quite elegantly integrated model, and that was contributed by PocketDoc, and they're using, and then also the AmChart by AMSys is using that same architecture. Mm-hmm. Yeah. So that's a pattern. That's an architectural pattern that I think we're going to be seeing more and more of, where you have to integrate a public blockchain if you want to mitigate any of the distorted incentives in healthcare. Yet you need to take advantage and comply with all of those other things. I'm sorry, Dr. Neal, I cut you off. Please.
Well, mine was really a question for both of you. Just we'll just flip it around for a second. But when it comes to, as we see more and more of these more small, like the private consortium blockchains, I feel like having developed, on public systems, one of the problems is the cost and scalability, for sure. I mean, we all agree on that. You can kind of overcome it by limiting the participants by doing a private chain. Do you feel like a large part of the reason for the current number, like you said, the majority are actually private consortium blockchains. Do you think it's really the compliance, or do you think it's that the public chains get shut down by, crypto kitties, or, that it becomes unusable with silly, the scalability part? You have to do your.
I think it's about control and mitigating risk, right? Healthcare, and perhaps rightly so, is risk averse, right? You can't be doing risky bleeding edge stuff with patient lives at stake. So with something like blockchain, healthcare is buying into it, but we're looking to control risk in as many ways as possible: privacy risk, security risk, compliance risk, and to your point, deployment risk. If you deploy in a public blockchain, even if you get past all the privacy, security, compliance headaches and challenges, then you have some viral app like CryptoKitties take off, and it basically effectively does a denial of service on your blockchain.
Yeah, exactly.
Unintentional. That's not acceptable if healthcare is doing sort of mission critical production stuff on blockchain. It won't happen this year, but into 2019, we do expect production use of blockchain in healthcare, and for healthcare to depend on it, they're going to want to control it. They're going to want to control the deployment environments, either on-prem or in the cloud, the things they own and they control, and they have somebody they can go to for support if something goes wrong.
And my reaction is I agree that those are the predominant factors today, but to counterbalance that point, one of the reasons those are the predominant factors is because healthcare organizations are taking every use case that involves care coordination, disease management, anything that touches PHI, and it's being moved down the roadmap. It's being moved out on the, to the right on the Gantt chart, if you will, and that's due to policy, regulatory uncertainty, and scale, and scale problems. So when you take out all the use cases that touch PHI and you're left with provider ID and supply chain traceability and things that add tremendous value and really can generate a lot of value in healthcare, then you're left with, well, there's not as much reason to use a private or to even worry about a public blockchain at all, because you're looking at optimizing existing contractual relationships, for example, between providers and a carrier, or between actors in a supply chain who all are contracted entities.
Yeah,
So,
I think what I'm seeing is, it's not that the use cases that deal with PII and PHI are getting kicked down the road. I think they're being dealt with. I think there's use cases being piloted this year that are going to involve PII and PHI. Just the key thing is the PII and PHI doesn't have to live on the blockchain. So you can reference a patient with a unique identifier on a blockchain that isn't, their social security number or date of birth or something that's PII, right? It's a unique number only for that blockchain on that island. And it's used to look up the PII for that patient in a secure access controlled off-chain database. So you can make sense, you can resolve that patient ID on the blockchain to the real PII if you need to. Same with the PHI, right? It can live, the protected healthcare information can live on a secure access control database off the chain. So if you think of blockchain as augmenting other systems, augmenting other enterprise systems, think of it all as one system, right? The PII and PHI is in there. It's just not on the blockchain.
And you're still speaking about a permission chain, correct? Not a public chain.
I'm speaking about it holistically. I mean, if you're doing a public chain, you're definitely not going to be wanting to put PII and PHI on a public chain. You'll be even more averse to doing that than you will on a private consortium blockchain.
Right.
Generally, the guidance I would give with PII and PHI is, and any data you put on blockchain is, you have to have a defined use case that you're going to be piloting on your blockchain. And the information you put on the blockchain should be minimal but sufficient to support that use case. So only the data elements you need, and if possible, avoid putting the PII and PHI on the blockchain itself, because that stuff can live in secure access controlled enterprise systems around the blockchain. And Dr. Neil, you were talking, I think, about GDPR earlier. So regulations like that can have, or data protection laws like that can have requirements, patients' right to be forgotten. If you put PII for a European citizen on a blockchain and they want exercise their right to be forgotten, you have a problem because that data is immutable. You cannot actually delete it. You can mark it as deleted, but the original data stays on the blockchain. So that alone is one reason why you want to try to avoid putting PII on the blockchain itself. If it's off-chain in a secure access control database and you get that requirement to delete it, or forget the patient, it can be deleted in that off-chain database, and it effectively de-identifies the data on the blockchain, so you can satisfy.
You basically create a dead link.
Yeah, exactly. I mean, and the metadata and everything is, the transaction history is still there, but the patient is not identifiable. And to your earlier point of, you can still potentially use AI machine learning to correlate that patient. Keep in mind that that is another reason why healthcare is doing the private consortium, is another, in security, we have a multi-layered approach. So that correlation you're talking about is a risk. Well, how do we mitigate that? We limit access to that data to only well-known, highly trusted organizations.
So couple of things just to give a heads up to the audience. We're going to be starting the Q&A session here pretty soon. So start thinking about the kind of questions you want to throw at Dr. Neil and David and I, and we'll be getting to that soon. Before we jumped into that, there was a thread I wanted to pick back up on with you, Dr. Neil, and I'd love to give you an opportunity to react to it as well. So as a pediatric anesthesiologist and the father of a young baby, you had a really interesting area of specialization, technically, clinically, and personally, around processing audio files. And I know members of our audience, we have AI practitioners that work on natural language processing and text recognition. We've got some imaging people. We've talked about many scenarios, but we've not talked much about audio. And maybe you could give just a little bit of a description about what you've done, and talk about it, as an anesthesiologist, talking airways and stuff about a baby's cry, and connect that back to maybe a vision for blockchain. And we don't have a lot of time for this, but it's such a neat topic and such an interesting scenario, and I imagine you'd like to remark on it as well, David.
Sure, yeah. So of course, as anything, I think anybody in our area, we build off of, nowadays, we build off open source. So some of this I've been reading about. A friend of mine mentioned that, he's big in computer vision and robotics, and I had mentioned to him all the noises in the hospital and how they're not recognized. We have archaic systems that beep. Every machine makes an alarm, right? Every pump beeps when it's empty, every bed alarms when you get out of it. There's lots of alarms in the hospital, and they're, because of the older systems, nothing was connected. So your options for hospitals are either spend a lot of money and upgrade all your systems to where they connect into your IT, or put a little microphone in every room that has a model built that can listen for the sound, turn it into the action, and transmit that into the EHR. So for a lot cheaper, you don't have to upgrade all your equipment. You just have to outfit some microphones around your facility. So that's where it started. That's actually where the Nursery Smart Hub started. I was building that system to do that, and then we found out we were pregnant and had to build a baby monitor. So that's kind of where
Isn't that amazing timing? Like, that is just uncanny timing how that worked out.
Yeah, so I'd started going down that line of research, and I found that the best current systems to do it were to utilize some of the open source libraries for computer vision and turn the acoustic samples. You take small clips and turn it into images using mel specs and some other things, and then look at it and train it as images. Just train it as looking for images that are similar. So it ends up treating the cry and other waveforms as images using the mel spectrogram, which is not new by any means, but it's able to process a lot more. Even the Raspberry Pi is able to process. I'm doing with the cry, I've set it to train on 1.5 second samples, and it's actually overlapping 3 in case a cry is between samples, it'll still pick it up. And then I'm just creating a confidence interval by summing up. I think I'm doing 10 right now. So if I get 10 positives within 30 seconds, I count it as an active cry. So that's for the cry side of things. That's how that works. But the goal is the system was written to be able to train it on hospital bed alarms, respiratory distress, all the sounds in the hospital that are currently no, they're nothing. They're just sounds in a hospital. To turn that into structured data, that's where that came from. And it's doing it all based on, thanks to Facebook and Amazon and Google and their work, and Microsoft on image, computer vision, sort of utilizing all that work and just cheating. That's kind of what it's doing. So
that's a super interesting project. I know, having had 2 children of my own, we could have really used something like that, and would love to see where you take it. Like if you developed it to the level of where it can tell you not just that the baby is crying, that like why, that would be super.
Yeah, the way that thing's programmed is hardwired in some baby Einstein and other things, and so they're structured as a list of peripherals, and so it starts trying to do things, and then it feeds back, did it fix the action? So we actually filed a patent on this system that is, it's acoustic detection and correction systems. So it's a way to detect an acoustic anomaly and then apply kind of reinforcement learning, but apply a set of actions and then learn which one works and keep changing over time, keep migrating the model. So like as a child grows, it's going to change. And then, so that's where that started. And that's why I called it snoozy, because I realized, God, you just want 5 more minutes. We push a button on the alarm. I wish we could do that to the baby. If we could just get 5 more minutes. So that was the goal.
Wow, that is a brilliant. You called it cheating, but it's a brilliant way to stand on the shoulders of giants, right?
Yeah.
And it's remarkable. So I think with that, anything you'd like to remark on with that particular scenario, David? Maybe connecting something along those lines to blockchain, or no?
Training advanced functionality, like to detect a cry, you might have enough data to do that within one sort of effort, one organization, like a startup, like what Dr. Neal's talking about. And I think you had some interesting ideas about crowdsourcing that. As you get more specific about what you're learning from the data, like you're detecting not just that there is a cry, but you're detecting that it's probably because the baby needs a diaper change or something. You're going to need much more data and much more specialized data. And for that, you really do need to source it from across a consortium of organizations, and even crowdsource it from mothers, right, that are willing to participate. Maybe you can incent them via cryptocurrencies and tokens, right, to participate.
Yeah, that's where it all kind of came from, because it started with that Facebook mothers group that I begged and donated to for sending in. They sent in about 80 clips, which was good. That helped me train the model. But I realized that's not scalable by any means. That's not scalable. So so again, blockchain is perfect for that.
Often wants millions of samples, not just 80 or 100.
Exactly.
And I think that's David, you hit on a point that we haven't really discussed much today, but that's another really interesting and compelling connection between blockchain and AI, and that's that so many AI training sets need expert validation, or they need to be generated by an expert of some kind and then fed into a body of training data. For example, mothers and fathers around the world being incentivized to have a system listen for their baby's cries, and then they capture metadata about that cry, that event, and it runs against other metadata, psychographics, demographics, age, time, all of those things, and the data set gets bigger and bigger. You cannot create something like that without an incentive structure.
Yeah.
Right.
And you have to have provenance and traceability for something like that, and that's true in the scenarios where you've had FDA and CE mark approval for devices. You have had expert validated models that were used for comparison and training. So there are token dependent dimensions of this to make it come together, because as you said, David, AI is very large data hungry, and that data has to be high quality, and you have to be able to filter it, to sort it. I assert that there needs to be standards around all that metadata. Otherwise, you're going to assemble data lakes, and you'd have to do a search one data element at a time, because you have no standard model. So there's interesting connections here that aren't just technical, but the behavioral economics of driving what it would take to get those validations.
Incentives and rewards, absolutely.
Yeah. Lots of connections. I think the three of us though all agree that it is blockchain is not a panacea that automatically magically makes AI happen. It's much more of an enabler, right?
Right. It's an opportunity to advance AI and machine learning to the next level, I think.
Yes, because what could we have done with AI already had we access to high quality, large data sets in order to answer these problems? Well, who knows? We haven't had access to those, only the very large tech companies with their own data.
Yeah, and in some cases, you find even in countries that have public healthcare systems that don't have some of the competitive sort of boundaries that impede the flow of data, they're all part of the same country. They're theoretically all on the same team. It's public healthcare, right? But still, they run into issues like in the UK with trust sharing data. There can be interoperability issues, system integration issues, all kinds of issues that impede the flow of data. So blockchain can really help, catalyze that sharing. If they at least know where the data is, and they can identify this data is exactly what I need, and then make arrangements to get it and assemble a lake, or collaborate via the blockchain to incrementally train the model. Because you could select out, okay, these 100 or these million data elements that you have, can you train this model with those elements, those exact ones? Because I can see based on the metadata, their baby's cries, and they were taken, when it was known that the baby was hungry. So those cries mean hunger, right? So being able to select out based on metadata and provenance to get a high quality, just to tie it back to the example Dr. Neil shared, to be able to train a very specific model, you're going to need lots of data from across organizations.
Yeah, absolutely. Well, hey, let's ask our audience our second poll question. We can talk while this is going on. So audience, our quick question for you is whether you would like additional, deeper content on blockchain and AI in healthcare. So we can do more events on this subject that deep dive into things like precision medicine, or eliminating preventable medical errors, or there's a wide range of topics, enabling value-based reimbursement and so on. Do you think that you'd like to hear more webinars that dig deeper into these topics, technically and functionally? So we've got about 60% of you have voted. Let's just get a few more votes in. We really appreciate it. And then we're going to open up to audience QA. We've got a half an hour left. I'm hoping you all have some really great questions for our panelists. There's definitely, I don't know what you think, David and Dr. Neil, but it really does feel like we've just tipped the iceberg of the subject, doesn't it?
Absolutely. Yeah, there's a lot of different use cases we could go deep on.
Yeah, exactly. Oh my goodness, look at that. So 89% of you say, yes, please give us more on blockchain and AI. Wow. Okay.
That's great. Good feedback.
I would say that's conclusive.
So if you have specific questions about it, help us out. Where would you like to know more? Ask your question, and we'll hit as many as we can.
Yeah, absolutely. So this is so you all know how this works. I end up juggling a bunch of things while we're doing this, but I'm going to take you on and off of mute as we go through the questions. Our first question is going to be from Karen Keeley, and let me find here. Okay, so Karen has a question about genomics and applying genomic data to the standard of care. I'm taking you off of mute, Karen. Hi there, Karen.
Hi there. Hi, how are you all?
Thanks for joining us.
First of all, I just want to say, so interesting. My mind is just racing right now. So many different things to touch on. But I'm a biotech consultant, and I'm also on the UN Global Health Committee. But this boils down to, I really think that genomics should be and will be standard of care at some point for everybody. So that's going to generate a lot of data. And since AI is very data hungry, what use cases do you see using all of that information that would be helpful to providers and solve problems so this will happen, so the roadblocks will be lifted?
Well, I'll kind of just start thinking about it as I speak, which might not go very well. So I apologize if this does this.
That's fair.
But
yeah. It's a big question.
Yeah. So genomics. I mean, I think in our big vision, once we have a large, large genomic data set that's also associated with, care data, the actual what care was provided. And let me just speak for anesthesia because that's what I do. If I had the genomics of all my patients, theoretically, in some way, shape, or form, and I'm able to slowly, if we all as anesthesiologists should be able to look back and see the tracer, and this goes to precision medicine, which Heather kind of spoke about, it's not a word, spoke about, that we might talk about in a different session, but to be able to determine what's the best anti-nausea medicine for this patient today based on looking at other patients that have been treated with this in the past. And I think that's clearly, I don't know if this is your question, because I think actually we all agree that that's needed and will come as we get more genomics.
Right.
That's not, not a beautiful thought. As for where the data is stored, I think, that's probably more of I guess for a David question, but I mean, my vision would be still these kind of personal private data lakes where you have to maintain control of that. Otherwise you end up with things like, I think there's a lot that's going to come breaking in these genomic testing that people have been doing with 23andMe and other companies on where your genomics are housed. There'll probably be, there'll be Facebook type data leaks from those, which will change the fundamental structure of who can own the DNA data. I think in the end, it'll probably, if people don't have the key, I think genomic data is so powerful that if anyone has administrative rights to storing that data, you're going to get hurt people, and it won't. I think that you'll end up needing to encrypt it and store it in a way that only the user or the patient can unlock. That's maybe not going to actually happen. But anything else that's less than that, any large stores of DNA data, though there's such a giant target that I think you're going to end up needing cryptographically encrypted DNA data stored, and you can share pieces of it. Again, Matt did do this, and I knew it was gonna. So maybe David and Heather have had a chance to clear their mind.
Several good points there I'd like to touch on. One is, genomic data is super interesting, and you have the SNPs rather, where your genome varies from a sort of baseline. And what do the SNPs mean, right? Does it mean you're more prone to a certain medical condition, or does it mean a certain drug is more toxic? We're kind of at early days of understanding what the SNPs mean, right? And we've kind of been targeting individual SNPs at a time. Where AI machine learning could potentially add a lot of value is understanding complex interplay between the SNPs. Like when you have this array of, this sort of permutation or combination of SNPs, this is what it means. So much more sophisticated correlation and understanding of what a genome means. What I would also say is, I think looking at one type of data, narrow type like genomic data, although it's incredibly rich, it's one type of medical data, right? Looking at one type of medical data really stunts the kind of inference you can do on it. And, just by way of example, we all know the microbiome can play a huge role in your health, right? So it's not just your own DNA, it's what kind of probiotics have you got, or, potentially, bad bacteria have you got around you. And so you'd want to take in lots of different types of data. And this is where AI machine learning can really help, is you're not just processing one type of data in isolation. It can take in so much data that a human would really struggle to get their mind around, what the correlations that could come out. But again, to train those models to take in lots of different type of data, you need lots of data to train those models and good metadata around that data. Like if you take a genome of one patient and, it's correlated with a certain medical condition, that's the metadata needs to be associated with that genome, so that when it's used in training, you can include it in a model that's looking for that condition. So the other point I wanted to touch on is privacy and patients having actual control of the data. That can be done without actually putting the data in the patient's hands. And I would argue that may not be a good thing to do. Is a patient good at protecting their own data? I'm not sure that that's true. A lot of healthcare providers struggle with protecting their own data, and that's one of the big reasons that they're moving the data into the cloud, because the big cloud providers have armies of security professionals which are securing them, and healthcare providers just struggle to staff the security professionals. If we're going to put the actual data in the hands of the patient, do you think the patient is up to protecting their own data? Probably not. So I would assert that it's probably safer to leave that data where it is and enable the patients to exercise their privacy rights via the blockchain, but not actually try to move that data to the patient, if that makes sense.
Yes, I agree.
So it does introduce all sorts of challenges, though, on the scalability of needing to compute on large data sets. And there it is possible to do some distributed models, but assembly of data, has other advantages. A couple of things I wanted to mention to your point, Karen, about barriers specifically. There are many engineering and cybersecurity barriers, for example, but there's also a tremendous amount of ethical policy and regulatory barriers that should not be viewed as unnecessary waste of time, but that really need genuine and deep thought and attention. There are two events upcoming that may be of great interest to you based on your question. One is on July 3rd, and it is with the CEO and the leadership team of a company called Encryptgen. That's business model is around cybersecurity, access control, and regulatory and ethics of protecting and using genetic data. That's on July 3rd, Encryptgen. And then on I believe it's July 18th, we have Kara Lapointe from the Georgetown Bleak Center for Social Impact that has created the ethical design framework for blockchain systems. And we're doing a 2-hour deep dive on ethics and applying ethics during blockchain projects, and AI is definitely going to be discussed. So both of those may be of interest to you.
I've written them down. Thank you.
All right. Well, thank you, Karen. I'm gonna go ahead and put you back on mute. I appreciate you coming on.
Thank you all. So interesting.
Thanks. All right. Our next question is from Aman Kadri, who I happen to know. Aman, thank you so much. I'm taking you off of mute now. He is the CEO of AMSYS Blockchain. And we mentioned him earlier in the event. You had a really interesting point that you made about also the genomics point. So it was a perfect segue. Hi, Aman.
Hey, can you guys hear me?
Hey, Aman.
Yeah.
Hey, David, how are you? Dr. Neil, appreciate what you guys are doing. Yeah, I was just, making a comment, in comparison to the last question, and the fact that we are wholeheartedly believe that genomics is, the next data lake that needs to be addressed. And our goal with our initiative is that as we're starting, our data gathering process in India, we're starting a series of heart and diabetes clinics and other things. We're actually going to work in conjunction with a genomics company to include genomics data as part of their medical record, because one of the Great Lakes that is voided is different phenotypes, right? I always have discussions with companies here that aggregate data, and they say, hey, look, we have very specific phenotypes of Caucasians or even Hispanics, but the things that we're missing are South Americans and Indians. And so our goal with it was as well, how do we create that huge lake of data that we need to run machine learning and AI process as well? We'll just, we'll work together in conjunction with doctors there and create hospitals and create those data lakes. And so I feel strongly the genomics and newer phenotypes are the new data sets that are needed for better AI learning in healthcare.
And for the audience, just connecting that back to blockchain, for anyone who's not aware, AMSYS has a PHR EMR blockchain-based product called AmChart that was mentioned earlier, and there's a recorded event in the recordings if you want to learn more about that you all could listen to. So thoughts on that, David and Dr. Neal?
You want to take that one, Dr. Neal?
Oh, I was gonna say, can y'all hear me?
Yeah.
Yep.
Am I echoing because my headset died?
Oh, yes. Big echo.
Okay, I'll keep working on it. You go ahead.
Okay.
Yeah, so I think it was a great point. I think, you know, there's a new frontier of data that's coming online now, and genomic data, phenotype data, microbiome data, all the omics really are fantastic new sources of rich data that are going to power new sort of insights. And, you know, to derive meaning out of that data, we really need AI machine learning. You know, Dr. Neal made a point earlier that, you know, doctors are drowning in data today. When you add these new data types and massive data types like genomic information, it's beyond the capabilities of a human doctor. And so AI machine learning it's not about AI machine learning replacing doctors. It's about doctors using AI machine learning to get a handle on this data and to use this data to the maximum extent that it can, you know, improve the quality of patient care and improve patient outcomes and reduce costs. But I would also add, I mean, it's not just about genomics and, you know, all that. It's, you know, consumer health data. You know, consumers are taking blood pressure measurements daily, and they've got all kinds of data coming from their Fitbits, and some have EKGs running on their smartphones. And this is all fantastic data that can flow into, you know, inference to help diagnose conditions, right? If you're, just in contrast, if you're looking at one blood pressure measurement when you go into the doctor once a year and you get white coat syndrome or whatever it's called, versus a measurement, you know, twice a day, every day for a year, you can get whole new insights from that. So we need to include all of this different types of data, not just genomic information. And I think the inference that can happen, the more interesting things can happen where we combine data types going into inference engines. We're not only looking at genomics, or we're not only looking at x-rays, we're looking at combinations of data to infer new insights.
Yeah, and Aman, one of the things to the point on earlier in the event, there was a high priority around healthcare innovation, and I just think it's noteworthy that what you're doing is turning the process we're seeing over where in, for example, in the U.S. health economy, we're all trying to figure out how to take an established healthcare delivery model and activate data silos, where you're going into a completely different health economy. Into areas where often there is very little built environment, very little healthcare delivery infrastructure, creating it from scratch with this in mind, from its foundations. It's a very different and innovative model, and one where we may be able to learn things more quickly that work for against different rubrics, and then bring those findings back into more legacy healthcare environments.
Well, yeah, well, I appreciate you being so eloquent. If you can give me a recording of that, that'd be great, because you give me way too much credit as an organization of trying to think about what we're doing. I think in the end goal for us is that, I agree with David, is that aggregation of every piece of data that you can get is vitally important. And that is our goal. Is we don't know what information we'll get, but what you get is you tally it all. And so that's what we're doing, like things with the mobile app. So the mobile app is designed to get data from blood pressure, blood sugar, EKG, all those data sets. And then we want to combine it with other things where, you know, a person's social history and medical and lifestyle, so in the end goal is, I don't know what we'll see out of that data. But my finite mind cannot process that. That's the tools that we developed with good data scientists and with good organizations. They're the brains behind it. And so, I can feed the data in there. They're going to handle the rest of it. So I think, people like, David and Dr. Neal and all these people that have ideas around AI, those are the people that are going to be, kind of be on the forefront of taking this data and showing us the insights that come from it.
Wow.
Thanks, Amon. You set a high bar for us.
Thank you.
No problem.
Appreciate it, Amon. I'm going to put you back on mute now. Thank you.
Sounds good. Thank you, guys.
Thanks a lot.
All right. Our next question I'm going to take is from John Fall, who has a question about how government agencies, he cited NIH, for example, can use both blockchain and AI. And I'm going to take you off mute here in just a second, John, so that you can speak with us directly. Right. Are you able to hear us? Or can we hear you, John? Oh, looks like we're having an audio challenge with you, John. I'm sorry. I'll read your question verbatim. You can probably hear us. How do government agencies like the Department of Health and Human Services in the U.S. or NIH best take advantage of AI and blockchain, especially the convergence of the two? Is it more on a case-by-case or research project basis, or is there some more general enterprise adoption ideas that can help facilitate this innovation in those kinds of environments? Terrific question. Thank you, John. Who would like to take that first?
Can you hear me? Okay,
yes.
Now? Okay, good. Sorry for the obnoxious Beats headphones, but my AirPods died. Okay, so I'm not familiar with DHS and NIH and what data sets they have, but in general, most facilities, we still have the data silo issue where they have plenty of public health data that they could probably use for public health research, but when it comes to specific disease progression outcomes measures, I don't think they have that robust, rich data set that that doesn't exist in this country. At least it's still siloed into hospital entities at the current moment, at least. So, but that's the place where blockchain that's what we've been talking about, where it could help try to integrate some of these, who has which data sets and who's willing to de-identify and share certain pieces. I think that's sort of a little bit of a grandiose vision based on how difficult it's going to be to get buy-in. But I think you'd need, unless David knows, I can't speak for what data sets they have to know what they can do, but if you're looking at the more holy grail of predicting medical disease progression, I don't think, as far as I'm aware, they're not going to have the data set of that continuous, detailed patient care data.
Yeah, let me add to that.
Thank you, Dr. Neal. I just wanted to let you know, I think we got it fixed and John is off of mute now. John, are you there? John? Okay. Apologies. Looks like that didn't work. It's fooling me. I didn't mean to interrupt you.
Not a problem. Just want to add a few points while we resolve the audio issues. But so, I mean, you say public organizations, that's such a wide umbrella, right? And if we look at like the Health and Human Services, they were actually incredibly proactive. I think they ran a blockchain challenge in, was it 2016, Heather? I think it was around 2016. They invited proposals how blockchain can be used in healthcare, and they got somewhere like 80 proposals, and they shortlisted that to 16. And it was really refreshing to see a public sort of regulatory organization like Health and Human Services take a proactive look at blockchain. And I think it underscores there are ways to use blockchain and remain compliant with regulations and data protection laws. But that's one organization. If you're talking about public organizations like the VA or CMS, I mean, they're sitting on massive volumes of data, right? VA is the largest hospital chain in the world. And so any healthcare provider use case for blockchain is going to make a lot of sense in the VA, typically. I think you've got a fantastic opportunity in those kinds of public organizations. And for AI and machine learning as well, right? You could look at the CMS and the data that they have and be able to run all kinds of advanced anti-fraud, AI machine learning. But I think the public organizations, even if they don't have the data, they have a potential role to play as a consortium builder. So building alliances, building consortiums of healthcare organizations, whether they be public or private, they could potentially build those consortiums and alliances and facilitate connection via blockchain. and advance AI and machine learning through the collaboration that happens based on those consortiums. One of the sort of softer things, the secret to success with blockchain is it's not technical. It's the hard part about blockchain is actually getting the organizations with the data to trust enough that they're willing to integrate their systems and transact on blockchain. And I think these public organizations have a role to play in building those consortiums and the trust and facilitating that sort of collaboration.
So I would like to comment. I agree with both of your remarks, and I'd love to point you, John, to a piece that Jim Zather wrote while he was at the CDC about this question, and it was a theme park view in terms of architectural blueprints that was applied at the Centers for Disease Control. You can find it on LinkedIn if you go to Jim Zather and look at his articles. It outlines this theme park view, but as an architectural blueprint to provide inside an enterprise that does control and possess absolutely vast quantities of data like HHS and NIH. That theme park view with microservices and the private data lake that can be used under certain circumstances is one first step. Another first step would be selecting an ethical framework that would be applied to the sound use of that data, and pursuing those two tracks in parallel. But there's great work being done, and there's some wonderful work that's been done at the General Services Administration at GSA, all inside the government. So not a blockchain ecosystem, but a terrific use of distributed ledger technology as a proof of concept that you could also look to. So
Heather, may I go ahead? Just have
yes.
If you're through with that, I just have a challenge that I want. This is just as a provider challenge for any listener. One thing that's one of the most difficult things for us right now, at least in this country, are the outcome measures. I'm not sure how much you're aware of this, but providers, when they're trying to measure providers' outcomes, right, not the patient outcome, not the patient predicting what's going to happen, but actually measuring how the providers do. That may be lower hanging fruit because your cost of missing that diagnosis, but you're not making a diagnosis, you're trying to measure high level providers or not. Currently, it's attestations of how well we did. We say we did well or not. This is a big deal in this country right now. It's what all the QCDRs are built around. If anyone has any ideas about how to build AI into predicting care providers' quality of care, which is what this is all about, there will be a lot. CMS will be happy to hear from you. This is a big struggle right now in this country, is to try to measure quality, to pay based on quality and not quantity. So just a challenge for any brilliant people who have any thoughts on that area. We're looking.
There's a company called Curisium that is a blockchain-based play looking at value measures, including by provider and by organizational unit and department and all these things. Very, very tough challenge, Dr. Neal, for sure.
Yeah.
So we are out at time, and we have tons of great questions left. I'd like to do a couple of quick things. I need to make a few announcements. And let me do that first, and then I'll invite you, David and Dr. Neal, to make closing remarks. And because we got such overwhelmingly positive reactions and we want more AI content, we will be doing more and going deeper on different subjects at this intersection. This entire event is recorded, as you know. So I'm announcing a new organization. This is a pre-launch. Our formal launch will be in July, but it is a 501c membership organization under the IEEE umbrella that will hopefully bring together stakeholders across healthcare in order to advocate for a policy and regulatory roadmap, spawn industry regulations, drive blockchain and healthcare specific standards adoptions, and many other things. If you're interested in being a founding member of Blockchain and Healthcare Global, please email me, reach out to me. look forward to speaking with anyone interested in participating at a formative level while it is being put together, because a rising tide does lift all boats. And a couple of announcements. We have 4 upcoming events scheduled, and another half a dozen or more in various stages of planning. On 6/28, we've got a terrific panel on blockchain and scientific publishing. We'll have Science Matters. We'll have one of the 2 co-founders of the Journal of the British Blockchain Association. We will have the CEO of Science Distributed, and a really an all-star panel of scientific publishers that are going to be looking at this. On July 3rd, we're going to be focusing on blockchain security and ethics and access and sale of genomic data with EncryptGen and their DNA token, which has been out and launched for some time now. And on the 11th of July, we are going to feature Simply Vital Health and their Health Nexus blockchain in detail with their CEO, Kat. That's going to be terrific. And then on the 18th, we have Kara LaPointe, Senior Fellow at Georgetown, on the blockchain ethical design framework and how we should apply it to healthcare. So I'd love to now invite you to make closing remarks. Maybe Dr. Neal, you could go first.
Yeah, I mean, I should have left the DNA question for your July 3rd talk. So that whoever asked that question, it sounds like what you want to listen in for, talking about genomic data and security. So yeah, I mean, for me, I mean, I think AI, with these are 2 kind of fields that are kind of going their own way with some cross connect that we're trying to put together, and they do have definite synergies. They're both developing so fast, trying to predict those synergies. As it's just tough. It's very hard to put them together. So you're trying to plan 2 different things that you can't predict a year out, and trying to put them into it's very hard for me in some ways to do this. I love both, and we can work together on the different areas, but I still think it's, for some, personally, I kind of think you pick one and that's sort of got to be your main focus, is either develop a great blockchain system or develop your great AI system. And then you can kind of, you can work on the other, but I find it personally, programming and working on it, a little challenging to try to do both at the same time currently, but that'll be different in 3 months. I mean, that's just today. So that's my closing remarks as a programming physician.
Thank you, Dr. Neal, and very, very appreciative of your time this evening and sharing your very wide and interesting experiences. Thank you so much.
Thanks for dealing with my ADD, Heather.
And yeah, just to add to that, I wanted to thank you both for a great discussion, and thanks to the audience, great questions, and for sticking with us for this time. And you know, just want to invite you to download the handout. It's available in the handout section on the webinar. There's a ton of information we shared. Feel free to go through that. Contact information's in there, social media. You know, some links to where you can dig deeper on either the AI, machine learning, or the blockchain side. This is a really interesting space because it's a combination of 2 of the hottest technologies, blockchain and AI, machine learning. So there's a lot of change. You know, I invite you to connect. I think we're all active on social media, so connect back with us. And you know, for those that are watching this on demand, if you have questions, you didn't have the benefit of this sort of live Q&A. Reach back to us with email or, you know, social media, message us. We'd love to get your questions and hear from you. Absolutely. So thanks again.
Thank you so much for joining us this evening, David. What terrific contributions, and what an exciting time to be at Microsoft at this convergence of AI and blockchain and healthcare, and leading that activity. That's just tremendous. So thank you so much for joining us. You too, Dr. Neal, and to a great audience. And until next time, with more events on AI, blockchain, and healthcare. All right, good night, everyone.
Thanks, everyone. Good night.
Good night. Thank y'all.